Right, good morning. We're talking about the mean value theorem. And I think I started out with an equation, didn't I? Okay, so if you take a look at this, there's two things that I'm going to underline. I'm going to underline in red the word continuous and differentiable. Okay, and so the example that I gave just at the end on that mean value theorem, and I gave you one where there's a parabola. And I think Reed showed us that there is a way to figure out where the vertex is by making the derivative equal to 0. And then I gave you x to the 2/3, and it came to a sharp point. That is the minimum. That was still the minimum value, correct? The relative min or the absolute min, that particular. But that I could not come up with a tangent line that was parallel to the secant line because of that sharp point. Does that make sense to everybody? So to use it, it has to be differentiable, or what we say in calculus is that the curve is smooth. Or if I take the limit of the derivative as I approach c from the left and the right, I'm going to get the same value. So I think yesterday the example that I was giving here, I gotta get a pen here, was this. Didn't I say that f of x is equal to x squared minus 3x minus 4? Is that correct? And I said we're going to have an interval 0 to 4. And I plugged in 0, and I got 1, 2, 3, negative 4. And when I plugged in 4, I got 1, 2, 3, 4, and got 0, so those are my endpoints. 0, comma, negative 4, 4, comma, 0. And then I took the derivative to see if we could figure out that vertex. We got 2x minus 3, made it equal to 0. And we got 1.5 is equal to x. And then when we plugged 1.5 into here, I think we got a negative 6.25, I think I said like a negative 25 fourths, okay, which is a negative 6.25. So here's 1.5, and so it's a parabola that kind of looks like this. It's differentiable, okay, because I'm told it's differentiable, but I also know it's a polynomial, don't I? And right here I could create a line that passes through those two endpoints. And this is my secant line. And the slope of that secant line, I think I determined was 1. Is that correct? Because I think I did like 0 minus a negative 4 over 4 minus 0 and got 1. Or what I could say, f of b minus f of a over b minus a. And the mean value theorem says I'm guaranteed for sure that there is some c between a and b where this is true. And if I take a look, I can kind of see, and I'll do that in a different color. I think I'll choose green. Somewhere right here. I don't have my ruler with me. I'll have to do this freehand. Something that looks like that, correct? I can figure out where that C is. How can I figure out where that C is? I know it has to be between 0 and 4, correct? But Jeremiah, really, there's an infinite number of numbers between 0 and 4, correct? How can I figure out where that specific number is? Say it again. I set the derivative. Can I call it c instead of x? Because I'm going to be solving for c, right? And I wanted to equal I'm going to make it equal to what, though? What slope do I want that to be? I want it to be 1, don't I? This tangent line has to have a slope of 1 if it's going to be parallel to this, right? Cullen, would you agree with that? Okay, so I'm going to make it equal to 1. So I'm going to get 2c is equal to 4, and so c equals 2. So right here at 2, I'm going to get a slope of my tangent line to be 1. And if you take a look, is 2 between 4 and 0? It is, isn't it? Math geekness. Does everybody understand that? You don't walk around the world talking to other people about derivatives, slope of tangent lines, slope of secant lines. That's geometry. And taking derivatives. But what you do is you do get picked up by policemen. That's happened to me several times. Most recently, have I told you I was doing a math problem? Okay, so this happened last year. And I actually tweeted this thing, and I live by North Junior High. So I get on Highway 15 and drive to the exit for County Road 29 to Mayhew Lake Road. Does everybody understand my path? So there's a stoplight on that, on Highway 15. McDonald's is to your left and Walmart's to your right. You understand where I am? Okay? I'm doing a calculus problem in my head. I put my phone away. I do not text and drive, totally. But every once in a while, my mind wanders, especially in the morning if I don't have enough coffee, okay? And all of a sudden, I look in my rearview mirror. I'm past that stoplight. A highway patrolman is pulling me over. And he pulls me over, and he's looking at me. And he's looking all over my pickup, looking for my phone. He's flashing the light, he's flashing in my eyes, because obviously I must be impaired in some manner. And I'm confused. I'm confused, one, because I didn't solve my calculus problem, and secondly, I'm confused because this person has interrupted my calculus problem. And I said, what can I do for you, officer? Because I'm extremely polite, because whatever I did wrong. He said, did you see me at the stoplight? I go, oh my gosh, did I see him at the stoplight? Anna, I don't even remember the stoplight. And then he says, you ran the stoplight. And I go, oh my God, I could have killed somebody. And I feel really bad. I said, no. He says, is there a reason why you did that? And I really wanted to say, well, I'm doing a calculus problem right now and you're interrupting me, but I didn't want to do that. Because I thought, well, I'll be in really big trouble. I'll be hauled away. And then he started acting to me like I'm old and decrepit. His manner kind of changes. Like, I'm dealing with an elderly person. I better be kind. Okay? And I said, no. He said, you came to that stoplight, and I was right next to you, and you stopped. And then you went. I said, I did? He says, oh, the left turn signal turned green. And I do remember that. I go, oh yeah, the guy to the left of me turned. And no one else was coming, so I said, what the heck? I'll go. Okay. The moral of the story, Hannah? Don't do calculus and drive, and if you do, it costs you $140. That's what that, so I tweeted that, okay? Then I forgot to tell my wife. And the Super Bowl happens. So it's been a month, okay? And everybody else in the abyss knows this happened. But my wife doesn't entertain the abyss at all. She doesn't go there unless she has to. And then she only puts her big toe into the abyss and gets out of there right away because she's afraid of being sucked into it forever. And so there was a Super Bowl party, and she went to it. I was ill. And she comes home, and she doesn't say anything. She's really quiet with me. And all of a sudden, we were driving somewhere, and she said, What's 20 times 7? I'm going, oh my gosh, she wants me to do a math problem. I got really excited. And I said, 140. She says, yeah. Why did you have to pay for $140 for texting? So she thought I was texting in the car. And I said, no, I wasn't texting. I was doing calculus. That does not help the explanation. So anyway, real world problem, dealing with math. So here's another instance, Cullen. If you drive on Highway 52, like I do quite often to Plainview, I go by a little town called Cannon Falls. You ever been to Rochester? Okay. Well, anyway, one of the most beautiful drives is between Cannon Falls and Zumbrota. Okay. So 2 stationary patrol cars are equipped with radar are 4 miles apart on Highway 52 south of Cannon Falls. I am passing the first patrol car and my speed is clocked at 60 miles per hour. Well within the speed limit, by the way. 3 minutes later, I pass the second patrol car and my speed now is 57 miles per hour. Well within the speed limit. I get pulled over and fined. Prove using the mean value theorem that I exceeded the speed limit of 65 miles per hour. How is that possible? I was going 60 and 57. Well, the mean value theorem requires, first of all, Kruger is traveling in a continuous and differentiable Now, it's because time. Does everybody understand that time is continuous and differentiable? Right? Everybody got that? Movement. Okay, so I got to make sure everything's continuous and differentiable. Okay, so the first thing I need is a slope of a secant line, but what I'm really saying is average rate. So my ordered pair is time, distance. Because when you take distance and divide it by time, don't you get a rate? So what are my points? That's why I'm saying slope of a secant line. I need 2 of them, right? What's one of them? Time and distance. Yeah. Okay, 4 miles apart. So there's a moment. When I go by the first patrolman, I'm at 0, 0. Would you agree? Right? I mean, that's when the stopwatch starts going. He's calling. He's on the other end of saying to the patrolman, black truck. Look out for him. Short, balding guy. Right? Because we're a menace to society. Every airport tells me that. So how much time? You said 4 miles for distance. How much time? 3 minutes. And I would agree with you 100%. What's the problem with 3 minutes? Do I want it in seconds? And I'm going to circle 60 miles per hour. I'm going to underline it. And I'm going to underline 57 miles per hour. What? I have to put minutes into hours. There are 60 minutes in an hour, correct? There are 30 minutes in a half hour. There are 15 minutes in a quarter of an hour. How many minutes are 3 minutes is how much of an hour? 1/20th. So I could say 0, 0, 1 over 20, comma 4. So I need those ordered pairs. How am I going to use them now? How am I going to figure out my average rate? Say it again. 4 minus 0, and those are miles, correct? Right? And 1 over 20 minus 0, and those are hours, correct? What do I get when I take 4 divided by 1 over 20? Right? I'm hoping you multiply by the reciprocal because it gets a lot easier. What? Yeah, my average rate between those 2 points is 80 miles per hour. So there must be a moment. In that time, I'm going 80, correct? So I'm saying there's an infinite number of times I exceeded 65 miles per hour, right? So my average rate is 80 miles per hour. So there must be at least. Right? Everybody understand why it must be at least? Could be multiple times, right? At least one moment in, and I'm not doing this very well, in 0 to 4, excuse me, 0 to 3, right? 0 to 3 minutes, where he exceeded, where he was traveling 80 miles per hour. There must be a time in there, a T, correct? A C within 0 to 3. You have to say that. It kind of looks like the intermediate value theorem, doesn't it? But the difference is I'm computing slope. I'm not computing position. I'm computing slope. Does that make sense? If you know some, if a function is differentiable, it is automatically continuous. If it's differentiable, it's automatically continuous. All of these, like I think this is supposed to be 2x to the fourth, 2x cubed. This is a polynomial. This is differentiable along in its domain. This is differentiable in its domain. This is differentiable in its domain. This is differentiable in its domain. Remember, the domain are only those numbers you can plug into it to get y values, right? Obviously, there's a x value there are x values that are not in the domain, right? But in the domain, it's differentiable, so it's continuous within the domain. Next page, okay? Rolle's theorem is really just a special case of the mean value theorem. It says, let f be continuous on a closed interval and differentiable. So if it's differentiable, you know automatically it's continuous. If f of a equals f of b. So that was this problem. Right? Remember I had a parabola? Here's f of a, here's f of b. They're equal to each other. They have the same y value. Well, that means the secant line is horizontal. That means the slope is 0. That must mean that there's a tangent line that has a slope of 0. That means there has to be a relative min or max at that C. So this is supposed to be f of x equals x squared minus 2x. And I'm going to start out this way. There are 3 things I have to show. I'm going to start out this way. F of x is differentiable. Since f of x is a what? I heard it. Polynomial. That means f of x is continuous. Since it is differentiable. Three, I have to show what f of a is. F of a is f of 0. A equals 0. Because that's my endpoint in my interval. What's f of 0 equal to? What? If I plug 0 into here, what do I get? 0. Then I'm going to b is equal to 2. What do I get if I plug 2 in there? Well, I'm going to have 2 squared minus 2 times 2. What is that? Isn't that 0 also? So that means f of 0 equals f of 2. So that means this should not be an x, this should be a c. That means there has to be a c that's equal to 0 if I put in the derivative. Well, I'm going to plot this. Here's 0, comma 0. 1, 2. Here is 2, comma 0. How do I figure out where that c is? Take the derivative, so I get 2. I'm going to plug c in there, minus 2, because f prime of x is equal to 2x minus 2, right? And I'm going to let that equal to what, Maureen? 0. So that means c equals 1. Is 1 between 0 and 2? Yeah, for sure. So if I plug in 1 into f, I'm going to get 1 squared minus 2 times 1. I'm going to get a negative 1. So right here is where my tangent line is parallel to my secant line. What does that mean? Well, it means that 1 comma negative 1 is an what? Absolute minimum. Done. Now, tomorrow there is not a quiz, correct? I said tomorrow I'd give you time to work, correct? The quiz is Thursday, correct? Okay. And you have a little bit of time right now, correct? All right. Is this making more sense? I think it was worthwhile to go through that activity in class. You see how they're connected? If I average 40 hours a week for work, that means there has to be a moment in the week that I actually am working at that rate, correct? I should think 40 hours a week. There has to be a time within the year that I am working at that rate, correct? There might be weeks in which I do more. There might be some that I'm working less. But there's at least got to be 1 week that I'm working 40 hours, right? That's the mean value theorem. As long as my work is continuous and differentiable. There is one question in which they ask you, can you use the mean value theorem? Make sure that your function is continuous and make sure that it doesn't have any sharp points. Does everybody understand that? The sharp points means it's not differentiable at that value. Okay?